Hi class, this is Juliana here, 10B part 2. We were just on this little question here. Is there more wood in an 80-foot high tree trunk with a radius of 2.4 feet or in a 60-foot high tree trunk with a radius of 3.1 feet? Assume that the trees can be regarded as right circular cylinders. So we have two right circular cylinders, 80-foot high tree trunks. So we have a radius of 2.4 and a height of 80 feet. And then we also have a second tree that is, I should do a bigger one with a bigger radius, if I'm going to be true to the form here, because the radius is a little bit bigger in this. But the radius here is 3.1 feet, and then the height is 60 feet high. All right, so we have those two tree trunks. We're trying to figure out which of the two have more wood in them. So what we're going to use is we're going to use our volume formula. Now, volume is a little bit different depending on what the base is. Usually your volume is the area of the base times the height. And that area of the base is different depending on if it's a cylinder like these are, or if it's going to be a rectangular prism or whatever. But it's always the formula for volume is always the area of the base times height. So that's how I always remember. Well, the area of the base of the cylinder here is a circle, area of a circle. So in cylinders, you have pi r squared is the area of the base times height. And that's how I always remember, no matter what the shape is, what the volume is going to be. It's just the area of the base times height. So if you have area of the base times height, we have pi r squared times 80, the height. And here we're going to have pi r squared times the height 60, right? So in our handy dandy calculator, I'm trying to find a spot where, I don't know, it's not the best lighting. So pi times 2.4 squared, and then times 80. And that's probably the best way to put that in there is you have pi and then the 2.4 squared and then times 80. And that is 1447.6. 1447.6. And that's volume and it's in feet, so cubic feet for that one. And then the next one, and I'm just going to arrow up and highlight that and hit enter because all I need to do is change this to 3.1 and the height to 60. So the radius and the height just need to be switched. And that's much easier than typing that all in a second time. And in that case, we get 1,811.4 cubic feet. All right. So those are the 2 cubic feet. You'll have to do a problem like this on the homework, and that's your first step is to figure out how much cubic feet are in each tree trunk. And then, of course, this 60-foot high tree has the most wood, and it's because it has 1,811.4 cubic feet, whereas in the other one, the 80-foot one, has 1,447.6. All right, so those are types of problems that you're going to get on the homework. Hopefully you've got that. Scaling laws, we're going to go back to our PowerPoint. So it's pretty easy to do that, and we're going to talk about scaling laws. Now, scaling laws reference a scale factor. Scale factor means that your scale is like, I don't know, maybe you've grown your prism or grown something with the scale from 1 to 2. If your prism, if you're talking about just a length, which would be your side measures, your height, your width, those are lengths. With a circle, a radius is the length, but you're just talking about a distance from one point to another. Generally, a side of the figure are going to be lengths, and they have the same scale factor as you would have normally. If you're doubling the length, then it would have a scale or a multiplier of 2. If you're tripling it, it would be a multiplier of 3. Now, areas are going to be a little bit different because all of a sudden we're not just talking about a length, we're talking about a whole area done in square feet or square units, whatever the square units are. So area scale with the square of the scale factor. So if you're doubling a length, then your area all of a sudden becomes 2 squared. You're going to square it. If you're tripling a radius, so if the radius is 2 and you're tripling it, the radius would grow times 3, so 2 times 3 would be 6. Your radius would grow to 6 inches or whatever. But if you're talking about the square area of the circle, going from a 2-inch radius to a 6-inch radius, then you've grown by a factor of 3. The area is going to grow by a factor of 3 squared, or 9. So any area is going to grow at a factor of 9. Now volumes are cubed. And so if I take the volume of the sphere, whatever that volume of the sphere is, if I've taken the 2-inch radius circle, and all of a sudden I'm trying to figure out for a sphere what the volume would be or how the volume would change, it will change by the cube of the scale factor of 3. So if the factor's 3 for the length, for the radius, then the factor for the volume would be 3 cubed, or 27 times. The volume would be 27 times as big. The area would be 9 times as big as if the length's 3 times as big. So anyway, those are your volumes. And I'm going to go to my page here so that I can do the remaining problems. So the length scale with the scale factor, area scale with the square of the scale factor, and volume scale with the cube of the square factor is what you should get. So basically, if it's 2, is the scale factor 2 squared would be the scale of the square of the square factor, or the area square factor would grow by 4, and the volume would grow by 2 cubed, or 8, grow by a factor of 8. So suppose that magically your size suddenly doubled. That is, your height, width, and depth doubled. For example, if you were 5 feet tall before, you are now 10 feet tall. By what factor has your waist size increased? Well, if it's your waist size, waist size is which one of these? Is it a length, an area, or a volume? Well, waist size is just the length around. It's the circumference, basically, of your waist. So that's just going to be a length, so it would scale in the same factor as your 2. What is it? Doubled? So it's going to be 2. So that means your factor for your waist size is increased by 2. Right? So if it was 30, say your 30-inch waist would now become a 60-inch waist. Wouldn't it be good? How much more material would be required for your clothes? Well, material for your clothes, that's going to be squared, right? That's area, surface area. Surface area is the material. And if it's a surface area, area is the key there. 2 squared, or 4 times as big, right? So if you used 4 yards before, now you need 16 yards. All right, 4 times 4. I'm going to write length here, circumference. For the first one, I didn't write it down, whereas I wrote down surface area. So I want to make sure I'm clear on that. Now, by what factor has your weight changed? Now, weight is going to be volume. I don't even want to know this. But your weight is volume. So it's going to be 2 cubed, or 8, right? 8 times. So if you weighed 100 pounds before, if you double in size, then you should weigh 800 pounds after you doubled in size. Crazy stuff there, huh? But it's true. All right, suppose someone builds an architectural model of a new office complex using a scale factor of 30. So he has this model of the office here. I don't know what it's going to be. And then he's going to actually build it, right? By a scale factor of 30. The height, sorry, you can tell I'm at work here.
Mr. Kreitzer or Katie, please come to the main office.
Okay, so the height then is going to be which of these three. That's all you have to figure out, and it's going to be a length, isn't it? The height is just the length, so it's the same scale factor. So it would grow with the same scale factor, 30. All right, that's 10A. Have a great day, guys.